Hello, everyone. How's everybody doing? I hope you can hear me fine this time. Uh, Last time, some people had problems hearing me. Anyways, want to remind anyone who is interested tomorrow, Monday, in the evening. I think it's 1900 Eastern Standard Time. I'm going to be on JFG's program again. We're going to be talking about energy. But today here I'm going to be talking about electricity. Okay. Now I was going to cover gravity today as well, but no, there's just too much material. And so one of the things I need to do is really look at all the steps necessary to understand electric universe gravity. Okay. So I need to go through electricity because that's what they're proposing. They're proposing that gravity is really mediated by electricity, that there is no real phenomenon known as gravity. Okay, we can refer to it as Newtonian gravity, but they claim to be able to simulate Newtonian gravity with electricity. So we do need to understand electricity, electric universe, electricity, one. And then the other issue is that, electric is in their name. Okay. It's like the flat earthers. They call themselves the flat earthers. Well, hopefully they can tell us what flat means. Okay. I went over that a couple sessions ago. And same thing applies to the electric universe. If they're going to talk about the electric universe and they claim that electricity is gravity, gravity is electricity, well, we need to know what electricity is, what it means at least to the electric universers. Okay. Okay. So where do we start? Well, we start where we left off the other day. I'm just going to summarize here what I'm going to cover, and it's these issues here. It's first one is what I call the von Daniken-Velikovsky syndrome, and that's essentially the main part there. Not that Daniken and Velikovsky had the same ideas, but what they had in common is this notion that our ancestors knew more than we do, and that they left us all these messages and so on. Were they wise? The people in the ancient days, yes, they were wise for mundane things, things like how to behave in society, or either or else. God was going to punish you. Wink, wink, nudge, nudge. That for that kind of thing, they were very smart. Uh, does this mean that they understood how nature works, how physics works? Absolutely not. They had no understanding of the natural world. That's why they had to invent spirits and gods and who knows what, angels. Okay. Okay. The next thing, the another irrationality of the electric universe, they emphasize experiment and evidence and proof. Okay. And why is that irrational? We're talking about irrationalities of the electric universe. Okay. Well, here's a rundown of that. What do we mean when we say irrational? We have a objective criteria for what is rational and irrational in science. It's not the science you learn in high school. We believe that wasn't science. And so we have what is known as the rational scientific method. And here are the criteria for what is irrational. If you treat a concept as an object and begin to move it around using inconsistent definitions or undefined words, the theory doesn't follow from the assumptions, describing mathematically, right, especially mathematically, and claiming to have explained a phenomenon. And then the mechanism that you propose doesn't really work or cannot be imagined. You can propose a mechanism, it doesn't mean that you can even imagine, or the crowd cannot even imagine what the theorist is talking about. Okay, so none of these things, experiment, evidence, and proof, really have anything to do with science, with rational science, and so we do have criteria for all this stuff. Okay. Okay. What's the next one? Well, definitions. Um, well, before we get into definitions, let's go over that a little bit. Here we have what science is not, And there you will find what I just mentioned, the experiment, evidence, and proof. You'll see experiment down at the bottom left there in the black area. And you'll have evidence, where is it? Right above it. And where is it? Proof, you'll find it on the next column, I think, somewhere. Proof, seek the truth. Okay, so none of that is part of science. Okay, so if that's what you learned in high school, in college, well, we're saying that's got nothing to do with science. In fact, we say it's got to do with religion. Okay, so what do the electric universes do? Well, they do present evidence, as I noticed the other day. Here you have it. They had a meeting, a conference in 2014, and they talk about evidence. And right underneath there, you'll see the electric universe is testable. Well, we don't test anything, and we do not present evidence. Why? Because the only purpose of presenting evidence is try to convince someone, is to try to persuade him to believe like you do. And that's forbidden in science, okay? We don't do that. In science, we just explain, you understand the mechanism, we're done, okay? That's it. And here's another take on that, okay? See if I can put it up there. This is one bit of evidence that the electric universe presents, and it's a visual. It's trying to convince you through images. They're saying, look, if you look at electricity in the night sky, which is on the right there, it matches what we see in space out there in the universe. And what is the problem with this? Well, the universe, if assuming that's electricity, what they're saying the universe is, the electric universe, right? All that should be permanent, where, in other words, ongoing, constant. Whereas the lightning that you see on the right, that's a one-shot deal. It takes less than a second, and there it is. Okay, so this is a bad analogy for how the universe works, even assuming they were correct and it works through electricity. Okay, so these things, again, they're trying to convince you through images, through persuasion, instead of explaining. That's the point. Okay, okay, let's go with definitions there. Number 3, I say that they haven't defined plasma or electricity, and these words are at the foundations. They're the cornerstones of the electric universe. If you're going to talk about electricity being a substitute for what we've always thought of as gravity, and you can't do electricity without plasma, hopefully you define those two words unambiguously. They're crucial to your theory, okay? And they don't. And so we need to know what a scientific definition is, okay? So let's go over that real quick. I'm not going to go in great detail, but yeah, we need to cover this base. And you can see there, its definition is a limitation placed on an extent or usage of a word. That's the definition, a scientific definition of the word definition. So if someone asks you, well, we can go and ask, what is a definition? Well, there you have it. That's what a definition is for the purposes of science, a limitation placed on a word, okay? Just very briefly, a scientific definition is rational if it can be used consistently. Definition is not equal to meaning. Meaning is what the juror gets, and prosecutor is who defines the term. So the prosecutor defines, and the juror is the guy who derives meaning from what the prosecutor defined. Concepts we define. Objects we point to. We don't point to concepts. You can't point to love. You can point to a heart. You can point to a dot. You can't point to a point, to location, or to an ordered pair. The meaning of a ordered pair. You can't point to that, to the ordered pair itself, because it's a location. Okay, you can't point to location, and so on down the line. So this is the problem. The problem is that all these concepts can only be defined. And so you can't point to a concept and treat it like an object. That's the issue, okay? Here's an example, for example, okay? Let me see if I can put this up here. Energy, okay? And this fellow on the internet says, look, what you're staring at, what you're looking at, what you're seeing is energy. Well, it turns out that energy is not defined as an object. Energy is defined as a concept, and if you look it up, it'll say something along the lines the capacity to work, to do work, or the capacity whatever. And you can't point to the capacity because capacity is a property or an attribute of an object, not an object, a standalone object in itself. And this is the problem. The problem is that they're using, in many cases, right, a concept to designate a physical object. They say we're going to transfer energy. What do you mean you're going to transfer energy? You can't transfer energy because energy is a concept. Okay, so this is the issue. The issue is that these people, are cheating in a way, right? They're um, they're trying to tell you that this object here, let me get this out of the way here. This object, which they're pointing to, they say that's energy. What do you mean that's energy? You defined it as a concept. And so this is the type of problem we run into. We run into that problem with both these words, plasma and electricity specifically. And I'm going to go over that today a little bit. Plasma, more so with electricity. Okay, what other thing do we have to say about definitions? Here, let me put this back up here. That we don't define every word in the dictionary. We can use normal words for ordinary speech. We only define those strategic words that make or break our theories. We only require the words that that you're going to use to make your case, your theory, or whatever you're presenting. Okay, operational functional definitions are outlawed. They're irrational, and because they're after the fact, they are formulated at the end of the dissertation. In other words, the whole dissertation is to try to prove the definition. And we don't prove definitions. We define, then we start using the word. And whoever uses operational and functional definitions does it exactly in reverse. Okay, they say, oh, look, I talked for the last hour, and now I'm going to tell you what I meant. Then they define the word. They say, see, everything that I talked about, that's what defined the word that was crucial in my presentation. No, that's not the way it works in science. That's why, when they use operational and functional definitions, like in the word wave, they use that a lot. They say, look, we ran this experiment, we did this and this, so obviously it's a wave. And that's the definition of wave because that's what we've been talking about for the last hour. That's the way to present it. That's irrational. You got to say, look, this is a wave, and now I'm going to present my case using this word. Okay, that's the way it should work. Okay, so that's the logic. What else? Well, that was it for definitions. Okay, so let's move on here. What am I going to talk about today? I want you to follow my train of thought. So I'm going to go through these different steps, okay? So here it goes, so that you see in advance what I'm going to talk about, okay? If I can get it up there. Okay, here it is. Okay, so these are the fatal shortcomings of the foundations of the electric universe. If you're going to explain a mechanism, you're going to need language. The question is, one question is, what language do you need? Do you need mathematics? Not if you're going to explain. Mathematics only describes, so we do not need mathematics at all in science or in physics. And a lot of people say, what are you saying? Yeah, I mean, let's define science, let's define physics, then we'll know whether we need mathematics or not. And if we define science as rational explanations, we have no use whatsoever, not only for math, but we have no use whatsoever for experiments. All we need to do is explain a mechanism. And as I always say, even blind men can be scientists, okay, physicists. Okay, science only admits rigorous definitions. You can't just fumble your way in there. The definition which is crucial, sine qua non, is the definition of the word object. You need to define what an object is. Why? Because we're going to be explaining mechanisms. We need to know what an object is. Specifically, we should be able to distinguish between an object and a concept. And again, you can't use a concept to point or to designate an object, thinking that you're designating an object. And three of them famous energy used to designate an object. We say, like I just showed just now, they point to the smoke, this little hazy halo there floating around. They say, that's energy. No, it can't be, because energy is defined as the capacity. Similarly, you can't point to plasma, because plasma is something in motion. It's not something, it's something in motion. It's more the in motion than the something. The something is what? As we said the other day, protons and electrons. So instead of talking about plasma, you got to talk about protons and electrons. Those are the actors. So if the sun has all this plasma going out there, you can't say plasma. You say, okay, over here we have the electrons, and over here we have the protons. What do? They clash, they hit, they do this, they do that. That's the electron and the proton. Those are the ones you got to use. You can't say plasma. Okay, you can't use that shorthand. That's the issue. Okay, and the EU, electric universe, it doesn't have the no definition for the word electricity. And you say, how can that possibly be? I mean, that should already make you stop and think. Here they have in their title, electric universe, electric in there, right? And you would think that the first word the electric universe has to define is the word electric or electricity, right? Because that's what they're going to be presenting. And here it is. This is their definition of electricity, or lack of. It's more lack of than definition. Electricity is a fundamental quality of matter. Okay, great. So it's used to characterize other things. Thus, consensus opinion is lacking precision. So they think it's a question of getting consensus, everybody voting for a definition or something like that. That's not the way it works in science. In science, you have to defend your definitions. You have to defend them with shield and sword against everybody who attacks it. That's what you got to do. You can't say, well, let's go into the room, let's all raise our hands, and a majority vote, that's the definition we'll accept. No, because you could be accepting an irrational definition if most of the people in there are irrational individuals. Okay? And then it says, like all bedrock presumptions such as gravity or time, reducing electric terminology into smaller units is impossible because it lies at the bottom of the lexical well. Okay, and what is electricity? According to what's a notion that the electric universe has of electricity? It says that we define as the flow of electric charge. Okay, whatever charge is, there's no physical object called charge, it's a concept. So the flow of concepts, that's very difficult. But then it makes it even worse. It says electricity travels. If electricity is the flow of charge, you cannot say that the flow of charge travels. That's what they're saying there, okay? Through a circuit, okay, whatever. Electromagnetic energy, well, energy is not a physical object, and it says flows. And people say, Bill, you're harping on a lot of words, on terminology, on word wizardry. This is semantics. We need to know what electricity is. We need to know what charge is. We need to know what energy is. If you're using concepts and you're introducing them as in physics as a physical object, you have a problem, okay? You have to go to the psychiatrist, not me. Okay, you got a problem because you're using all these concepts and you're treating them as objects. It's like if you're saying, what is electricity? Well, it's love. Okay, and what is love? Well, love is this feeling that we have. We have these vibrations in our body. And love now travels. What do you mean love travels? Didn't you say it was a vibration? How can you say that love travels if love is already traveling in the definition of love? And that sort of thing. Here we have a problem. And here we have another case, electricity moves through a DC circuit. How can electricity move if electricity is the flow of charges? Does the flow of charge travel, move, etc.? And we look up charge and then says property of matter, okay? So we have charge, which is a property, it's an attribute, and they're going to treat it as a physical object. They say, oh, it's a particle of charge. What do you mean a particle of charge? What nonsense is that? This is idiocy to the 10th power, okay? And so if this is what you learned in electricity, if you took electricity at, say, the high school or college level, well, you got a problem because you never understood what charge is. All you know, it's a value that you're going to put in an equation. These people are saying there's a particle of this number, of this value, and then it's going to move. So yeah, the language is critical here. And that's why they can't define the word electricity, and that's why it lies at the bottom of the lexical well. Okay. So yeah, all these are the issues that we have to resolve. And people say, "Well, I don't want you to do semantics. You're boring me with all this stuff." You need to understand what the problem is. If you're going to run away from definitions because you can't define them because it destroys your religion, you have a problem. Okay? No, we need to really define these terms before we use them. That's the way it works in science, in rational science. In mathematical physics, they do whatever they want. You know, they don't define energy, they don't define mass, they don't define force or time, and they start using these words and they start bending them. You know, bending time, warping time. They unite it with space and create space time. You know, they do all this idiocy. It's idiot talk. And the electric universe is doing exactly the same thing. Because where did they learn the language? They learned it from the establishment. When you go to high school, when you go to college, who's teaching you the subject matter? Someone who's already gone through the system. Okay. Okay. What else do we have here? Next in line here we have, yeah, you don't have the electric universe does not have a definition for the word electricity. Okay. And, but they think of it as a flow of particles. That's how most people in the electric universe and also in the mainstream, right? That's the way everybody imagines it. Specifically, they're talking about electron beads. That's what everybody learns. You know, you got all these atoms, and you got these electron beads, and one or the other. Either the bead goes all the way to the end, or it just bumps the bead on the next atom next to it out of its position, which bumps the next one and which bumps the next one. In other words, it's like a chain reaction, so to speak. Okay. That's the notion people have. And there's too many problems with that. Just too many problems. Here, let's look at some of them. Here's their notion, and it puts it in the right perspective here. It says, this comes, I should have put the reference, but I think it comes from one of their books, okay? Our star is a component with two electric circuits. They're going to explain, you know, how electricity binds the entire universe. Why, you know, that's what's called electric universe. They're going to mediate it with electricity. It says, one interstellar and the other local to the solar system itself. Without exception, all electric and magnetic circuits must be complete. No kidding. So they're going to run a circuit through the universe here, okay? Keep that in mind. In order for current to flow and for magnetic fields to exist. The colossal interstellar maintenance currents that flow into the sun enter its north and south poles. Okay, so we have all this current they're saying. They're coming from other stars, from the entire universe. It goes into the sun through its north and south poles. That's the idea that they have, okay, that electricity is flowing through our sun. The other internal solar system circuit has positive protons drifting away from the sun through the heliosphere to the heliopause, and negative electrons drifting from all regions of the heliopause back to the sun. What are they talking about? Well, let's see if we can illustrate this, okay? Here it is. Okay, this is the solar system with respect to the universe. And here you have what they're talking about. They have the sun at the center there, the little planets. Here's the sun. As it drifts away, you can see the planets there, and you can see how small we are with respect to the bow shock, the heliopause, and anything related to not only our galaxy, but to the universe at large. See how small we are? There you see it, okay? So that we have all these barriers, okay? And they're saying that electricity somehow flows from interstellar space into our sun through the north and south pole, okay? This is their argument. And that somehow, you know, all this extends all the way to the planets and beyond, okay? Okay, so let's get this in here. Okay. Give me a second here. Okay. So they have this cosmic electricity. So let's look at this. Let's look at this cosmic electricity. Here's the way I illustrated it. Okay. You have the sun serving as the anode, and the planets not really serving as a cathode. What they're saying is the cathode is less positive than the anode. That's how they explain it. Okay. And so what they're envisioning is that, these electrons, they're flowing, um, I guess, from less positive to more positive. Is that what's happening? Or even if you do it in reverse, because they have two versions of electron flow, but it doesn't matter either way. This, first of all, requires that there be a plasma. That's very, very important. But more significantly, it requires that we explain the atom. We need to know what ionization is here, because that's what they're showing there. They're showing ionization, and that which is the loss supposedly of an electron from an atom. And they're going to represent it as the flow of electrons from one terminal to another. That's essentially that's their notion of electricity. Well, let's see if this flies, okay? Here you have another vision of this, and this is voltage. Okay, and when you're in high school or college and you take a course in electricity, what they show is that there's a bunch of beads going. These are batteries here in both cases. What they're showing is a bunch of beads going from one terminal to another. Okay, comparison, you see the rope hypothesis. There's no flow of beads. What it is you have one terminal that's going clockwise, and the other terminal had better be counterclockwise. And that's what voltage is under the rope model. But in the first case, you see that it's the flow of electron beads. So we have to somehow justify that. In other words, we got to look at their atom at this point, because it's not clear how these beads first become separated from their atoms and how they begin to flow. Okay, so this is what we're going to look at. We're going to look at the atom. We're going to look at ionization. We're going to get deeper and deeper and deeper to find out where the problem is with the electric universe. Okay, that's what I'm trying to do here. Okay, here's another vision of voltage. This is how they explain it. And again, you can see that they explain voltage as a difference in potential. They usually illustrate it with water flow. I mean, this is ubiquitous. You'll see it everywhere. They'll say, we can explain it with this analogy. Imagine, a big tank. It's got all this water, and you got a little pipe, and you got the other terminal, in this case, the bathtub there, and water flows from up to down. Okay, and yeah, you use gravity for that, but let's forget about that for a second. What they're saying is the water, in this case, flows from positive to negative. What is it that's flowing? Well, water. And what is water? What do they have in mind? They're having in mind particles. Okay, that's what they're thinking of. They're thinking of particles. And again, if you compare it against the torsion version of the rope model, where we have just clockwise on one end, and it ends in counterclockwise at the other end, you can understand that these are two different analogies for the same phenomenon. So we have two different theories here of what voltage is. Okay, one is the mainstream and electric universe and everybody in the universe, and the other one is the one from the rope model of light, which is torsion. And one of the issues here is that, Mother Nature, she doesn't understand what positive or negative is. In fact, the electric universe has never defined positive or negative, neither has the mainstream, because it's a mathematical concept. But Mother Nature understands clockwise and counterclockwise. That she understands. That's physics. That is physical. You turn something clockwise, and the other end, it's got to be counterclockwise, okay, if you look at it from the other end. So Mother Nature understands that. She doesn't understand positive and negative. What is positive in physical terms? What does positive mean? Or are we going to do like Stephen Hawking did? He says the universe started with zero energy. Huh? What do you mean zero energy? It started from zero energy? Yeah, because you take positive energy, negative energy, and you put them together and you get zero energy, no energy. And then you can separate no energy into positive and negative energy, and that's how you create matter. So that's how they explain the creation of that little point that becomes the Big Bang. Okay, so it's up to you whether you accept such theories. Okay, who came up with this positive, negative, and charge? Well, good old Benji Franklin. Okay, he's the guy who invented all this nonsense. And he says electrons move from areas where there are excess of negative charges to areas where there are deficiency or positive charge, whatever positive and negative means. Electrons move from negative to positive, okay? But conventional current is considered to move in the other direction. When you set up a circuit, conventional current is considered to move from the positive to the negative side. So again, these people, it's very hard to follow their presentations because they're saying, well, negative electrons are supposed to be attracted towards the positive um, terminal, okay? But as you can see, the conventional current is to move from positive to the negative side. So I don't know, you figure it out. If this doesn't confuse you, well, I don't know what does. They have to make up their mind what thing is flowing. Are the protons flowing towards the negative terminal, or are the electrons flowing towards the positive terminal? Okay, so they have to figure this out. And, under the rope model, it's the torsion of all these interconnected atoms that causes electricity. Electricity is not a flow of particles. Electricity is a worm turning in place. That's what electricity is. It's a torsion of a string of atoms. Okay, so we have a different model, we have a different theory of what it is. But it's interesting what they say next. The idea about using positive charges in forming explanation comes from Ben Franklin. Franklin said we didn't know about protons and electrons. So Franklin believed that something moved through electric wires, and he called these things charge. In fact, that's where they got the idea of flow. Okay, because everybody thought that, and still thinks that, electricity is the flow of something. What are they talking about? Flow of electron beads, independent beads. So yeah, we're going to have to get down to what this bead is and what ionization is. We got to get down to that level to find out if there is any irrationality. And we'll find out that there is, okay? Anyways, he assumed there was only one kind of charge, and he logically assumed the charge would flow from a spot that had an excess to a spot that had a deficiency, okay? And that's what we inherited, okay? Essentially, we got all that from good old Benji. Okay, so let's get Benji out of here for a second here. Okay, so yeah, at some point you're going to have to get down to the ion, okay? You're going to find out what it is. And why? Because you can't do universal electricity unless you do plasma. Unless the entire universe is covered somehow with plasma. And that's what these people are saying, that the universe is completely covered with plasma, okay? So it's important to understand that. And so one of the questions we have, which I covered the other day, I'm not going to go in this in great detail, but we have to ask, what is plasma? Because that leads us then to ionization and eventually to the atom, okay, which is where we're headed. Okay, so here's a plasma universe. They're not the electric universe, but essentially these people think in the same way. What is plasma? Well, whatever it is, it's something in motion. They're talking about charged particle. Charged is an adjective that suggests motion. And just in case, you have the word moving, lost, and stripped. So plasma is something that is in motion. Something is happening to the atom, and that's why plasma is not a standalone object. You can talk about electrons, you can talk about protons, but you cannot talk about plasma as being an object. And that's the first irrational, the big irrationality of the electric universe. Here's another illustration of that, which I always show. The one on the left is a gas, and gas is not the same thing as plasma. Why? Because plasma is something in motion. You have to do something to the gas. The object is the gas. The thing is the gas. And again, all these are synonyms in rational science, whether you say medium, agent, thing, something, all these are synonyms. There's no difference between the word object and thing. On the other hand, plasma is a concept. It's a dynamic concept, okay? And as you can see, you don't see it standing still. It's moving all around, okay? And yeah, in order to understand this, you need to understand what ionization is. And here you have the official version. Ionization means that the atom has lost an electron. In this case, we're looking at the simplest of atoms, which is the hydrogen atom. We have a proton in the center, and we have an electron. Okay, and the electron just flies away for whatever reason. And that's called ionization. In other words, what happened here, the proton now that atom, or what's left of the atom, is a positive ion. Okay, that's the way it's seen. Okay, so this is a positive ion, which means protons somehow are positively charged, whatever that means physically. And it's good for mathematics, terrible for physics, but that's what ionization is. Okay, so here's just the final thing on this interconnectivity. Here you have two galaxies, and what these people are saying is that electricity flows from one galaxy to the next. And yeah, in order to do this, in order to imagine this, you have to cover, the entire universe with plasma. Okay, you can't do it without plasma. You can't do it without some material thing. Now, the only other thing I'm going to say here is that quantum mechanics has gotten rid of the atom. They only accelerate electrons now. That's what they claim. That all these beads, they just do electricity with beads and they forget about the atom altogether. What they accelerate at the beam lines, such as CERN and SLAC and so on, they just talk about electricity. In other words, they talk about accelerating electrons, and they never talk about the fact that these little beads are dependent on the atoms, on the ions that serve as a base. Remember, the electrons supposedly move from atom to atom. Well, they've forgotten about that. Today that's gone. That's no longer true. Okay. Let's get this up here. That's no longer true. What we have today is just the flow of electron beads. Okay, so what's the issue here? Well, cosmic electricity requires a mediator, plasma. Okay, plasma is not a thing; it's a concept. So you can't say that you move the concept or that you're going to deal with a concept. You're going to be handling a concept, especially in the lab. I don't know how you're going to, juggle plasma. And ionization requires that you illustrate an atom. And that's what we're going to be doing next. Let's find out what the electric universe atom looks like. And that's important because that's where electricity is going to have its foundation. You're going to have an atom. You're going to ionize the atom. You're going to somehow pull the electron. And then you're going to compel it to flow from atom to atom. Okay, that's the notion of electricity that these people have. So let's look at the atom. Okay, and here we have Walt Thornhill's atom, and he's one of the head honchos of the electric universe. Okay, so let's see what his atom looks like. He says, when we apply a force, again, applying a concept to a body, I mean, you could say I apply a rock and then you would understand it, but you can't apply a force because now you're describing, you're not explaining what you're applying. It's like saying I'm going to throw a force. No, you can't throw a force. You can throw a ball, not a force. Okay, but that's the language these people have. They're going to apply a force to a body, whatever force is. How is that force transferred? They're going to transfer forces. And this is not just semantics. No, this goes to the root of the fact that they're using concepts as physical objects. So keep that in mind. That force transferred to overcome inertia. That we're going to overcome another concept, inertia, whatever inertia is. I've never seen a piece of inertia, never drew it, never saw an illustration of inertia. And the answer is electrically, by the repulsion between the outer electrons in the atoms closest to the points of contact. So what is he talking about? Well, he's talking about the planetary atom. That's what he's talking about. You can see it just about everywhere. All subatomic particles, including the electron, are resonant systems of orbiting smaller electric charges of opposite polarity. He's talking about positive, negative. He's talking about charges. He's talking about orbiting particles. So what is he talking about? He's talking about Niels Bohr, Ernest Rutherford's planetary atom. Okay? And so a little question that you got to keep in mind, which I'm going to be dealing here with, is how do you keep the electron bound to the proton? That's the issue here, okay? But this is what they're saying. They're saying, look, we have all these particles and they orbit, okay? They're going to say they're orbiting the proton, okay? And just in case you think that I'm picking on him, no, here I have another version. And this is from their book, the one they recommend. Okay, and here you have also a vision of what the atom is. What is an atom? It says up there, an electron has a negative charge, a proton has positive charge. Well, what does negative and positive mean? What is an electron? Are we talking about a little bead orbiting a bowling ball? Is that what we're talking about? Well, yeah, that's exactly what they're describing, because you can see there the structure of an atom can be described as follows. At its center, it has a nucleus that consists of one or more subatomic what? Particles. That's what it has. And you see the picture there. The nucleus is where we find all protons and neutrons. What are protons and neutrons? Particles. Okay. Electrons, of which there can also be one or many more, whiz around. Okay, so they orbit, right? This nucleus in shells at set distances from it. And see, you can see the picture there, and the color, the green color, I put that in there. Okay, their atom was without that green color. So what is that E1? That E1 is an electron, and it's orbiting the nucleus. Okay, now why did I paint that green area? Because I want to know what's in that area that keeps the electron bound to the proton or to the nucleus. You need to define that. What is that green stuff? And I also drew the little red line tethered to the nucleus, and I want you to tell me what that. I mean, if that's what's holding the electron E1 to the nucleus, you need to define what that little line is. I need to know what physical object is in there. Otherwise, you're using magic. You're using witchcraft and tell me, oh, the electron just stays, tied to the proton. Well, that's a description. You haven't told me the mechanism of how the electron keeps bound to the nucleus. That's the problem. And the next thing that they say in this book, which is relevant here, is we now know that plasma fills all of space. In fact, we don't know, or let's put it differently, because we don't use the word know in science. Okay, it's not that we know exactly the opposite. Experience and measurements. I mean, if they like measurements, if they're going to introduce measurement into physics, well, experience and measurements and every test out there shows exactly the opposite, that plasma does not fill space at all. Forget about all of space. Okay, and again, you can see they say distant stars are sun, planets are charged bodies immersed in a conductive medium. What are they talking about? That famous plasma that they think is a medium. That's the issue here. Okay, what's wrong with your atom? Well, the one thing is the one that I just mentioned. That is that you need to tell me what binds the electron to the proton or to the nucleus. Here's another big problem with with the planetary model. Okay, here it is, illustrated. Okay, and what you see there, especially, I want you to focus on the p orbital, which is that figure 8 orbital there. And you can see the electron, which is negative, goes right through the positive nucleus where we have the protons. It just goes right through. And p orbitals are a big problem for quantum mechanics and by extension to the electric universe, because you say, hold it, this guy's negative, goes right through the proton. And you'll see other illustrations of this. They're trying to avoid the problem, and they say, well, it comes close, but it doesn't go through there, because the electron really doesn't describe a full figure 8. It just can be found in that region. That's the way they explain it. Well, still, we have a problem, because when the electron comes close to the proton with a positive proton, why doesn't it get sucked in by the proton? I mean, if positive attracts negative, as they say, whatever that is in physical terms, why doesn't the electron get stuck to the proton? I mean, you got to explain this. You can't just wish it away and move your magic wand and say it is so. Yeah, I know it is so, I mean, in your model, but you haven't explained anything with that. You haven't explained the mechanisms. That's the point that I'm trying to make here, okay? Okay, how do they explain the electron being bound to the proton? Well, I don't know if it's an explanation, but this is their argument, okay? And again, this is the same argument of the mainstream, so I'm not telling you anything new, okay? And what they have here is they say it's a force. Oh, no kidding. And they're going to call that force an electromagnetic force, whatever a force is. A force is a force, of course, right? This force gives us the structure of the atom itself by binding binding. They say the force binds electrons in their orbital shells around the central nucleus. Well, no, a force cannot do that. That's only that all you're saying is that there's something there that binds it. You haven't explained the mechanism. You haven't told me how the electron is physically bound to the nucleus. And that is the big problem with quantum mechanics. They cannot draw to this day their atom. They cannot tell you what their atom looks like because they cannot explain what binds the electron to the nucleus. And so the way they describe it, or really describe it, is they say, look, the electron can be anywhere in this region around the nucleus. Yeah, great. Okay, that's where the electron bead can be at. Okay, we can understand that. Why doesn't the electron just spontaneously fly away? That's the question. Why do we need to ionize it, somehow kick it for it to leave its orbital? What is this orbital? Why is it stuck in there? That's what you got to explain. And that's what quantum cannot explain in the electric universe by extension, because they use the same atom. And they say it's a two-way force. It is attractive and repulsive. And again, there's no explanation of why. It's a long-distance force. Why? If it's a long-distance force, why doesn't the electron fly away? None of these questions are answered either by quantum mechanics or electric universe. And I like to punchline that we just do not yet fully understand this all-encompassing role of the electromagnetic force. And you never will. You never will, because when you deal with particles, which is what quantum and the electric universe, propose, you can't explain anything. Because it doesn't, you can't model light, you can't model gravity, you can't model the atom, you can't model anything with particles. And the big issue there, the strategic issue, is you're missing the force of pull, which is what holds the electron to the nucleus. That's force of pull is what you got to explain. And they never discovered the force of pull. In fact, if you look in all of mathematical physics, anywhere from Newton all the way to Stephen Hawking and beyond, even to these days, the big problem is the force of pull. It doesn't exist in mathematical physics. They never discovered the force of pull. The way you pull on a donkey, you throw rocks at it. That's the way they pull. Or they remove the matter between you and the donkey, and the matter behind both of you pushes you the two together. That's the way they explain either one. One is the Casimir, which is this last one, and the other one is the negative momentum transfer. And both are irrational idiocy. It's just nonsense. And so the electric universe, if they're going to use the model used by quantum mechanics, they've got the same issues on their plate. They got to answer these questions. How do you produce the force of pull? That's what we want to answer. And one of the reasons why is here you have a statement that puts it all in the right perspective. Okay. And you can see these are statements by Walt Thornhill. He's from one of the head honchos of the electric universe, probably the most important fellow there. And he says there are no isolated islands in an electric universe. And he says, all these things that we have there, they interact continuously. Continuously is very critical here. Not only interact, but continuously. Why? Because they're saying you got a permanent connection. And there on the bottom, you see the universe is connected. Okay, it's connected. And so how do you connect things when you have beads? How do you connect things with little marbles? Have you ever tried to connect one marble to another and pull on it or do anything? They're going to explain gravity, right? And they say positive attracts negative. Okay, so how do two little balls, one positive, one negative, do it in your own lab at home, in your basement. Just take one tennis ball, put a plus sign on it, take a baseball, put a negative sign on it, and see if they attract each other. By what mechanism? This is the problem. The problem is they cannot produce the force of pull, okay? Okay, just in case, here you have another version, and again, their atom is the planetary model, okay? So all the people from the electric universe use this model, and they cannot tell you why the electron bead doesn't fly away. That's essentially the big problem, okay? Okay, let's move on here. What are they trying to explain? Well, they're trying to explain this vision that they have of filaments, okay? You can see they're obsessed with these filaments. They think that you're staring at electricity going from galaxy to galaxy, star to star. That's the issue. Here's another picture of that, which I've made, okay? And you can see it here better probably, okay? You can see that they have this notion that electricity is running through there. And you would have to have all these lightning bolts and plasma, that the little white dots in the background there, you would have to have that all over this scenario. Maybe you can't see them, fine, we'll concede that, but the question is, you're going to have plasma in order to have that all those electric bolts going from star to star, galaxy to galaxy. Okay, so this is what they're proposing. Okay, and you got to figure out if this is how the universe is run with all this electricity. And yeah, if you're going to have plasma, you're going to have atoms in there, unless you do it the quantum way, which is quantum does it with only with electric beads. Okay, they electron beads. In other words, quantum mechanics has gotten rid of the atom completely. They don't use it anymore. They say, look, we're accelerating electric beads. And if the electric universe is going to adopt that notion that there are only electrons flowing from galaxy to galaxy, now we don't even need plasma, because plasma is ionization. You have to have the ion. You have to have the what's left. After you pull the electron, you're going to have an atom there that is charged positively. That's called an ion, right? And now if you get rid of that, now you don't need matter at all. You can't talk about plasma. Now you're going to have to talk about electron beads flowing from galaxy to galaxy, just the little beads, flow of them, gazillions of them. Okay, so keep that in mind. We've changed the paradigm here. Okay, there's a new paradigm shift. Okay, what's the problem with all this? Is there all this plasma out there in the universe? Well, all I can tell you is that the flat earthers, they don't believe in the round Earth. They believe in the flat Earth. And their argument, to defend that posture is that humans have never gone into space. Because if we went into space and could have taken a picture or filmed the globe, that'd be, it's like proof, evidence, here it is, here's the globe, right? And so it's easy. You just say, well, humans never went into space, all that's fictitious, all that's fake. Okay, fine. The problem is the electric universe, they do accept that humans went into space, okay? And just in case, there are members within the electric universe. There are many members there that don't believe that humans went into space. I want to clarify that. You will find many electric universers saying that humans did not go into space. But the official posture, okay, is that humans did go into space. And how many times did we go into space? To the moon. To space we went many times, but to the moon, okay? That's an interesting point, because I'm going to talk about vacuum, okay? And so this is what the EU believes, okay, the official posture, okay? And that's, we went into space these 6 times. You find it all in their Thunderbolts project in YouTube. You can look these up, these titles, and you'll find that they argue, as a matter of fact, that, yeah, humans went to the moon. And you can see all the Apollo missions, 11, 12, 14, 15, 16, and 17, all put humans on the moon, okay? Now, what's interesting about this? What's interesting about this is that if the electric universe accepts that Apollos went to the moon officially, and they say, yes, man, went to the moon, and they start talking about, in fact, they show pictures of the potholes that the craters, that asteroids left by hitting the moon. So they show that as evidence that man went to the moon, okay, among other things. Okay, but if you're going to accept that man went to the moon officially, then you have to accept also the conclusions and some of the experiments that these gentlemen did when they were on the moon. And number 12, Apollo 12, 14 and 15 and 17, those 4, they measured the vacuum on the moon. And you cannot ignore that. You cannot say, yeah, man went to the moon, we did all these experiments, but we never measured the vacuum. Okay? And why is this important? Well, it's important because, they train you, not for the flat earthers. You can leave now if you want. You'll put your unlike and you can go. But for those people who believe that, that accept that humans went to the moon, we trained these guys in Ohio. In fact, they're trained. And one of the ways they're trained is they're put in a vacuum chamber, because they have to get used to the sensations of what they're going to be experiencing when they're out there in space on the moon. Not only in the moon, but even before getting there, you got to go through space, right? You might even do a spacewalk for all we know. So what happens? What's the issue? The issue is that they have a chamber and they pump it down. Do they pump it down to the vacuum level on the moon? No. They pump it down to -6 torr. And the moon has -11, -12 torr, which is a much greater vacuum. You've got nothing there almost. Very few particles in comparison to what we have here on Earth in normal pressure, normal atmospheric pressure. And you say, why do they test them at -6? I mean, you're putting these guys in danger. You're testing them at -6. Now you're going to send them to the moon where there's -11, -12. Are you crazy? So let's understand why. The reason is that, and I'm a vacuum guy. I work with plasma, vacuum chambers, and so on. And one of the things you note, I mean, I worked many years with this. Don't ask me, are you an expert? It's not a question of being an expert. You're going to be an expert in 2 seconds. In 2 seconds, because what you need to know is what I'm going to tell you here for the purposes of this discussion. And that's this: that if you pump a chamber down to -5, -6 torr, you can still get what is known as arcing, a thunderbolt. Zeus sends his bolt, goes zap, okay? And that's not good for production. I work in the semiconductor industry. You have to put electrical characteristics into wafers, then cut them up and put them in dice and package them and sell them. And you cannot pump down the chamber to just -4 or -5. You got to go beyond that. We pump down to -7 level, okay, -7 torr. And why did we do that? The main reason, again, is arcing. You don't want to have a dirty chamber and have all this unwanted arcing. And when you go to -6, -5, you can still get arcing. At -6, -7, you no longer have arcing. Okay, I've never seen it, but you got to have a dirty chamber to have arcing. What does that mean? They put these guys in the chamber not because of the vacuum, the astronauts. They test them at -6 because they know there's going to be no electricity. Forget about the vacuum. It's not an issue of vacuum. If you can withstand -6, you can withstand -11 because there's fewer particles. And so it's not like you're going to blow up, and say, oh my God, the suit already protects you against vacuum. And it doesn't matter if you do a -6, -7, -12. It's going to be the same as far as vacuum is concerned. The issue is electricity. Why do they test at -6? Why did they design the chamber where they test astronauts to the -6 level? Because they know at that point there's going to be no zapping. You're not going to kill the astronaut, okay? And so it's tested at -6. And at -6, they know they're safe, okay? What does that mean? It means that if you go to the moon and you measure -11, -12 range, well, you're not going to get any electricity because there is no plasma. There is no plasma in the sense that, you might get a little bit of plasma near the sun and so on, yeah. But there is no plasma in the sense that you can run a continuous current. That's the point. If you want to have an AC or DC circuit, you're going to have continuous flow of electricity, which is what these guys say binds galaxies together, one to the other, and the Earth to the sun, all the planets. You're going to have a continuous current. You're going to have a continuous current only if you have plasma, and that plasma has to be at around -3 level as a minimum, okay? And so here, let me show you a little chart, which I like to show because for those who are not familiar with these things, it helps them visualize what kind of thing vacuum is, okay? Here it is. Okay, let's see if I can put it up there, okay? Here you have different vacuum levels, okay? We pump down to the -7 in chip manufacturing. Then we have to fill the chamber back up with argon, an inert gas, and we have to ionize the argon, and we have to take it up to 10 to the -3 level to perform the operation where we sputter a target, for example, or whatever we're going to do in there. You can etch, there's different processes. But the point is, in order to produce an electrical current in there, a continuous electrical current, you need to raise the vacuum, the pressure in there by introducing an inert gas. And what's typically used is argon. Okay, so now you have 10 to the minus 3. Now, yes, you have a plasma in there, what is known as a plasma, and now you can run a current. The moon has 10 to the minus 11. There's anywhere between 50,000 and 200,000 particles per centimeter cube. And you say, that's outrageous, that's tremendous. No, no, it's not. See, here on Earth we have millions of particles per centimeter cubed. And in the moon, it's almost a perfect vacuum, which is called 80,000, 50 to 200,000 particles per centimeter cube, which is anywhere in the 10 to the minus 11 to 10 to the minus 12 torr. Interstellar, they calculate, they don't know, but they calculate that it's got to be anywhere above 10 to the minus 16, maybe up to 10 to the minus 19. Those are calculations, okay? So you have even fewer particles, interstellar and intergalactic, okay? So there is no plasma there to do electricity that the electric universe pretends to bind galaxies with, okay? This is the issue. And just in case here, we have a report from the Apollo 14. This was an official report, and you can see the pressure on the moon. What they did, they left the device that measures. It's known as a cold cathode ion gauge, okay? And what happens is they measured over several years, and they realized, what the values were. And it's 10 to the minus 12 torr in that range. The solar wind is even more less dense, in other words, rarer. Okay, it's even thinner. It's got only 10 to the minus 13 torr. Okay, so you can't really do any electricity out there. Anything above 10 to the minus 5 torr, you get into the minus 6, minus 7, you're not gonna have electricity, and this defeats completely what the electric universes propose. Okay, so conclusions. Let's see if we can get down to the conclusions here. Okay, these are my conclusions for today. Proponents of the electric universe do not define their strategic terms that they're going to use, specifically plasma and electricity, which are the cornerstones of their theory. Okay, both words are defined as objects. They're not. They're concepts. Okay. And they also use the motion of electrons, and we have a problem because their atoms don't work. You cannot do electric universe atom. Okay, you cannot rationalize it. That's the issue. You have to use witchcraft to use the planetary model. Okay, this is a non-trivial. It's not semantic issue. Okay, people say, "Oh, you're doing semantics, word wizardry, you're doing word games." No, this goes to the root of the theory. That's why these words need to be defined, okay? Because both plasma and electricity versions of the electric universe assume that electrons are negative. We don't know what negative is. And, that it orbits the positive nucleus. So we got the problem negative, positive. We have the negative electron going through the positive proton or near it, not being captured, okay? And then you have the issue of negative and positive. We don't know what that means in physical terms. So, I could have called them X and Y. I could have called them yes and no, black or white. I could have called them anything. What is negative and positive? And that's what they need to explain. And of course, they're never going to do that because they say, well, we don't understand it quite well. No kidding. You can't even start your presentation until you understand it well. And I want you to understand, I'm not talking about Mother Nature's atom. Let's keep that in mind. I'm talking about the atom, the theorist that's at the microphone, the atom he's going to use to explain his theory. So I'm not talking about the real, the real McCoy, the atom that Mother Nature uses. I'm talking about the one he's going to use to explain his theory. He's got to rationalize that, and they can't do that, not with particles. Okay? And then if electron beat orbits the nucleus, the proponent has to explain the mechanism that prevents the spontaneous escape of the bead, okay, etc. And the final one there, the EU electric universe purports to replace Newtonian gravity, and I'm using Newtonians. They're not replacing; they're just giving another explanation for Newtonian gravity. Okay, let's keep that in mind. They plan to do it with electricity, but there is no electricity level plasma, in space, near the moon, in the solar wind, nowhere in the universe. Out there in the universe, you get 10 to the minus 11 and upwards, or downwards, whichever way you want to look at it. You go to 10 to the minus 12, minus 13, minus 14, and so on down the line. Out there in space, you don't come close to anything we have here on Earth. Why? Because here on Earth, we have all this air that protects us, and we have high pressure. We're so used to that pressure that we think the whole universe is like that. It's not true. When you get out there, if you're an astronaut and you believe that astronauts have gone out there in space into the moon, well, you know better. You know that out there you have very low vacuum. When you have low vacuum, you have no plasma. You have no plasma. You have no electricity. Next time I'm going to do gravity, and that'll be the third installment. Hopefully I'll finish with the electric universe there. I just wanted you to understand that first, plasma is a problem, electricity is a problem. Now we're going to find out that gravity is a problem for the electric universers. We'll see you on Wednesday. Wednesday? Yeah, Wednesday. We'll see you on Wednesday. Bye-bye. And don't forget, tomorrow night, all those who are interested, I'm going to be on JFG's program. We're going to be talking about what? Energy. So if you like energy, if you have a lot of energy, well, meet us tomorrow at, I think, 1900 hours Eastern Standard Time. We'll see you then. Bye-bye.